In level 47, we're going to finish talking about the different types of solids so that we can round out and know more information about them. So molecular solids have discrete molecular units at each lattice position. So some common examples would include dry ice, which is carbon dioxide, frozen in solid form, sulfur, and certain forms of phosphorus. These solids are characterized by strong covalent bonding within the molecules, but relatively weak forces between each molecule. So for example, it only takes 6 kilojoules of energy to melt 1 mole of solid water, but it takes 470 kilojoules of energy to break 1 mole of the OH bonds. So that's an example where it's a lot easier to break the intermolecular force holding the molecules together, but it takes a lot of energy to break the intramolecular force, the covalent bond, that's holding the O's and the H's within the molecules together. The forces that exist among the molecules in a molecular solid depend on the nature of the molecules. So many have no dipole moment and are held together by London dispersion forces, which is the weakest of all the forces, as we've seen before. As the size of the molecules increases, the London dispersion force becomes quite large, causing many of these substances to be solids at 25 degrees Celsius. So, in the picture, we have sulfur crystals in the left picture, A, that have 8 sulfur atoms bonded together, as shown in the blown up picture of the molecule. And B is a picture of white phosphorus, which contains 4 phosphorus molecules making up 4 phosphorus atoms making up 1 molecule. And it's so reactive with oxygen that it has to be stored underwater, but it doesn't react with the water. So those are 2 examples of molecular solids. Ionic solids are stable, they have high melting points, and their substances are held together by very strong electrostatic forces, the ionic bond that is existing between the oppositely charged ions. Their structures can be explained by close packing spheres, like we saw before. Typically, the larger ions, usually the anions, which are usually larger, are packed in one of the closest packing arrangements, and then the smaller cations fit into the holes among the closed packed anions. So, the packing is done to maximize the electrostatic attractions among the oppositely charged ions, and then minimize the repulsions with like charges. So, this is kind of showing you that as you go down, the hole size increases versus trigonal, tetrahedral, and octahedral. And so that allows for more or a bigger cation to fit in that space. These pictures are found on 481 in your textbook. The location of the X is showing the holes in each of them. So that would be a tetrahedral hole right here in A, or blown up in B. And then in C, that is a picture of zinc sulfide, where the sulfide ions are in yellow, and they are close packed with the zinc ions in red, where you have that tetrahedral shape happening there. The picture down below is a very common picture that we see. It's sodium chloride, where the X's in picture A show where the sodium atoms will fit in to fill in those spaces. This table is in your notes. It's a summary of all the different types of solids. Atomic, we can have network, metallic, or group AA, which are not very common, molecular, and ionic. So you can use this to help you classify substances. So you're going to need to know this like the back of your hand, okay, before you take a quiz. So for example 3, using the table, let's classify the 4 substances here according to the type of solid that it forms. Well, gold is an atomic solid with metallic properties, because Gold is just gold. It's not in a compound, it's just the atom. It is a metal, so that would make it have metallic properties. Next, carbon dioxide is a molecular or covalently bonded solid because it contains the nonpolar CO2 molecules. The lithium fluoride contains ions because it's made of the lithium ion and the fluoride ion, so that would be ionic. It's a metal with a nonmetal. And the last one is krypton. This would be an atomic solid with the noble gas properties, which is group 8A in the summary table. So that's how you could classify those. This is the end of level 47. Please check your checklist to know what to do next. I've been awake for a while.